In this lesson, we're looking at how we can find the distance between 2 points on the Cartesian plane. Now, the way we find our distance is related to Pythagoras' theorem. And you can see here that we can easily make a right-angled triangle where we have A, B, and C. So we can use Pythagoras' theorem, which is c squared equals a squared plus b squared, to find this distance here. Now, just to show you how that works, here we have a distance of 2. We're going from 0 to 2, which is 2. Here we have a distance of 3. We're going from 1 to 4, so that's 3. So we can then put that into Pythagoras' theorem. We're going to get c squared equals a squared plus b squared. So c squared is going to be 2 squared plus 3 squared, which is going to be 4 plus 9. C squared is going to be 13, and c is going to be the square root of 13. So we found the distance there. Now we're going to look at an easier way, or rather a formula we can use to do that. So looking back at the Pythagoras theorem, which does make up an important part here, we still have a, b, and c. So we have c squared equals a squared plus b squared. Now, if we look at this a, this distance here is going to be this value, this x value minus this one. And if we were to label these points, here is going to be our second point, so x2, y2, and here is going to be our x1, y1 point. So if we're taking this x value, subtracting this one, our a is going to be the same as x2 minus x1. The same thing happens with our b point, which is going to be y2 minus y1, because here we have our y2 point, and here is our y1 point. And just to check, we are going for minus 1, which gives us this distance here, which is 3. So now we have those values, we can substitute them into the formula. So we have c squared equals x2 minus x1 squared plus y2 minus y1 squared. And then finally, we can work out our distance by square rooting the entire equation. So we get x2 minus x1 squared plus y2 minus y1 squared. And now, because we're looking for a distance, and it's not explicitly Pythagoras' theorem now, this would usually be written as a d, the distance. So this here is the formula for the distance between 2 points on the Cartesian plane. Okay, and here I've just rewritten it for you so it's a bit neater. Notice that it doesn't matter which order these two come in. You could swap the x2 minus x1 squared with the y2 minus y1 squared. But these two need to be added together, and then you need to find the square root of that as well. Okay, so we're going to use our formula now to find the distance between these 2 points, or the length of the line. Here we have our x1, y1 point, which is going to be 1 minus 1. And we have over here our x2, y2 point, which is going to be the same as 5, 2. Now we can use the formula, so d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Substituting our values in, we're going to get our x2, which is over here, the 5 minus 1. So we're going to get 5 minus 1 squared, plus, and then the y2, which is 2 minus minus 1. So 2 minus minus 1 squared, which then simplifies down to the square root of 5 minus 1, which is 4 squared, plus 2 minus minus 1, which is 3 squared. We keep going, we're going to get 16 plus 9, and our d is going to be the square root of 25, so d is finally going to be 5. Okay, in the second one, we want to find the distance between these 2 points. And this is easier because we have our x1, y1, and our x2, y2 already given to us, and we don't need to work them out. So d is the square root of x2 minus x1 squared minus y2 minus y1. Plus. Now make sure that you always set out your working with this formula first. Then we get d is the square root of 3 minus 2 squared plus 12 minus 6 squared. So we get d is going to be the square root of 1 squared plus 6 squared. D is going to be the square root of 1 plus 36. So finally, d is the square root of 37, and that's the distance. Okay, now it's your turn. Find the distance or the length of this line. Okay, we're going to again use the formula. Both of these are squared, and we have our points -2, -3, and 10, 2. So now we're going to put those into the formula. We're going to get 10 minus -2 squared plus 2 minus -3 squared. So our distance is going to be 12 squared plus 5 squared. So we're going to get square root of 144 plus 25, which is the square root of 169, which is going to be 13. So that's the distance for that one. Finally, find the distance between these 2 points. Okay, so we have x1, y1, x2, y2, and then we're going to use the same formula. All right, then we're going to have the square root of 2 minus -2 squared plus 4 minus 1 squared, which comes 4 squared plus 3 squared, the square root of 16 plus 9, and hopefully you can see where this is going. We're going to get 5. Okay, if you have any questions, please let me know. Otherwise, continue on with the work.